All right, so I'm going to go ahead and look at the third example real fast. And so what we're going to do is we're going to use the volume by shells method, and we're going to calculate the region as y equals 9 minus x squared over the interval from 0 to 3. And we're going to take that region and we're going to revolve it around the x-axis. Now, in this specific example, it said it really wanted us to use the shell method. Now, in example 1 and example 2, we both of those examples had problems that were really much better suited for the shell method because the disc or washer method really was not going to function very easily. It was not going to make my life simple. And so what I wanted to go ahead and do in this case is it says specifically to use the shell method, and you're going to see why I mentioned that in just a second. So here's what I'm going to go ahead and do first. I'm going to go ahead and graph this y equals 9 minus x squared. I'm going to go ahead and graph that first, and we'll get started. So I'm doing it over the interval from 0 to 3, so I'm going to go ahead and plug in 0. 9 minus 0 squared is 9. 9 minus 1 squared makes 8. 9 minus 2 squared makes 5. 9 minus 3 squared makes 0. Now, so the region that I'm working with is this half a parabola over here in the first quadrant. It looks like this. Now, we're revolving it around the x-axis, so it's going to look kind of like the same thing on the bottom. I'm going to just go ahead and plot a couple of points that are going to look like they're in the same place. Just to try to make my graphing look a little prettier. All right, so it's going to look almost like this bowl-shaped thing. Notice it's one solid piece. It's not going to have a hollowed-out center like a normal bowl would. If I were to try to calculate this using disc or washer method, the disc method worked really well because you notice if I sliced it right here, it makes a nice, pretty disc. And so it would actually be pretty nice to calculate this using the disc method. In fact, it wouldn't be very difficult at all. It says to revolve around the x-axis, so I would leave it in terms of x and calculate it that way. In fact, here's what I'm going to do. I'm going to suggest to you guys, if you're watching this video, use it as an example. Take it as an exercise to calculate this using the disc method. But here's what I'm going to do. The exercise, the example says to use the shell method. So I'm going to show you how to do the shell method with this example. And what you can do, if you do it by the disc method, you can compare our answers in the end, see if we got the same thing. So here's the thing. In example 1 and example 2, our shell method had the y-axis as the axis of revolution, and so we left it in terms of x. In this case, I've got an x-axis as an axis of revolution, so I want to make this in terms of y. So that's going to make this slightly harder. All I've got to do is turn this into y's, and you'll see what happens. So I'm going to move this 9 over, so we're going to do y minus 9 equals negative x squared. I'm going to go ahead and change the sign, so we're going to have 9 minus y equals x squared. Notice negative 9 became positive 9. Positive y became negative y. Negative x squared became positive x squared. I'm going to square root it, and I'm going to make sure I mention something in a hot second. So normally when we square root something, we always put a plus or minus out in front. I'm not going to do that in this case, and here's the reason why. In this case, I have a parabola, but I only have half of it. I don't have both sides of the parabola. I've only got this one side over here. So in this case, I don't want the plus or minus because the minus represents this side in the second quadrant. I only want this positive side in the first quadrant. So again, I'm only using positive here, even though normally we do plus or minus. So now that I've mentioned that, I'm going to go ahead and look at this. So I'm ready for my shell method. In this case, this is the function I'm going to use, but I'm going to do it in terms of y. So here's what we got to figure out. I've got to figure out what my bounds are first. In this case, if I'm using y values, I'm starting here at 0, and I'm going all the way up to 9. So I'm going to integrate over the bounds from 0 to 9. 2 pi, my radius, again, if I'm using the y values, is the y itself, not x this time. All right, the other thing I'm going to do is multiply by this function that represents the height of the cylinders, which in this case is the square root of 9 minus y. Now I'm going to go ahead and make sure I show you that in this case, my cylinders are actually going to go this way. So I'm going to have a cylinder that represents this block, and it's going to swing all the way around, and it's going to encompass this part here. Okay, so my shells are going to kind of sit on top of each other, but they're going to go sideways in this case. They're not going to go up and down. All right, so now that I've written this, I'm going to remind you again, I can pull out the 2y. That's going to make, 2 pi. It's going to make my life a lot simpler. So I'm going to take out the 2 pi. I've still got the integral from 0 to 9 of y times the square root of 9 minus y. Now, honestly, you might get to this place and be a little bit stumped and say, I'm not sure 100% on what to do. Here's the thing. There's one really powerful method we talked about integrating when we just aren't quite sure what to do. And the really good method is U substitution. And you're probably thinking, hey, that's a really great idea, Mr. Harold. I see that square root of 9 minus y. I probably want to do a U substitution there anyways because it's a square root. And that's a great idea. So here's what I'm going to do. I'm going to write that as U equals 9 minus y. That's going to be my U substitution. So when I calculate the derivative of U, the 9 disappears, the y just becomes a 1. So it's a negative 1 dy. Now, that means that what I need to do is I need to make sure I put a negative up here when I do my integration. So I'm going to just put that negative out front just to make my life simple. So I'm going to have negative 2 pi. I'm going to go ahead and calculate my bounds of integration using u instead of y, just so I go ahead and do that substitution fully. If I plug in 0, 9 minus 0 is 9. If I plug in 9 minus 9 is 0. So now I'm integrating instead of 0 to 9, I'm going from 9 to 0. That's an important fact. Now, I'm going to keep going, and what I'm going to do is I'm going to go ahead and switch that square root of 9 minus y out for u du. Now, the only thing you're probably wondering about is, what do I do about that y right there? What do I do with that y? Well, let's also write it in terms of u. So here's what I'm going to do. I'm going to take this u equals 9 minus y, and I'm going to turn it into just a y, so I know what to switch it out for. So I'm going to move this y to the other side, so it's going to be y plus u equals 9. Then I'm going to move the u to the other side, so y equals 9 minus u. Now, that's going to make my substitution actually pretty nice. What I'm going to do, instead of having this y right here, I'm going to write 9 minus u. Then I'm going to distribute the square root of u. So I've got negative 2 pi over the integral from 9 to 0, and it's going to be 9 square roots of u minus u times the square root of u. Now, hopefully you guys are thinking in terms of exponents. That's going to be u to the 1/2. That's going to be u to the 3 over 2. And I'm also going to make sure I mention one of your other properties, one of the other things you're probably thinking about at this exact moment is, what about this negative and those bounds? Well, here's the easy fix. If I think real hard about this, what I can do is I can actually take this negative and I can make it switch those bounds. Let me repeat again one more time. When you switch bounds, you change the sign. Well, I've already got a negative. It's going to make my life easier if I switch it back to 0 to 9 and turn that positive. So let me rewrite this. 2 pi, integral from 0 to 9, again, switch the bounds, change the sign. And then that's 9u to the 1/2 minus u to the 3/2. So what I'm going to do with this part is I'm going to go ahead and integrate. Don't forget your 2 pi up front. That's going to integrate to become, I'm going to do 9u, and that's going to become 3 over 2. So I'm going to multiply by the reciprocal, which is 2/3. Then I'm going to subtract u to the 5 over 2, because again, we're bumping that up. And I'm going to multiply by the reciprocal, which is 2 over 5. Okay, again, we're integrating, or we're evaluating from 0 to 9. So what's going to happen here is this 9 is going to turn into a 3, and that 3 is going to disappear. So 3 times 2 makes 6. So I'm going to write this. 2 pi times 6u to the 3/2. Again, 9 times 2/3 makes 6. Minus, I can't really do anything with that 2/5, so I'm just going to rewrite 2/5 u to the 5 over 2, evaluated from 0 to 9. Now let me remind you, if I were to plug in 0 here, it's 0. If I were to plug in 0 here, it's 0. So all I need to worry about is plugging in 9. So let me write this down real fast. So 2 pi, and then I'm going to do 6 times 9 to the 3/2 minus 2/5 times 9 to the 5/2. All right. Once I type all that in the calculator, my magic will be working. So let's do 6 times 9. I'm going to be very, very careful. To the 3 over 2, or 1.5. Then I'm going to subtract 2/5 times 9 to the 5 over 2, or 2.5. And that gives me a whopping 2 pi times 324 over 5. So my final answer here, if I do this correctly, 324 over 5 times 2 pi makes 648 pi over 5. Now, I'm going to make sure I mention this to you. If you use the disk method, it might actually be easier in this case. but I wanted to make sure I did an example using the shell method where I had to switch it into y's. Okay, so making sure I pointed this out again real carefully. Again, some problems you can do either way. You can do disk method, shell method, wash method. It doesn't really matter which method you use, but some methods you really need to use the shell method. So, glad I pointed all that out. Hopefully that helps clear everything up. If you got any questions, please make sure you talk to me about them.